All right, our next session is entitled BI, Toolkit Powered by Natural Language Processing. And I would like to present Sandra Martincic, Ipsic, Head of Intelligence Systems Chair at University of Rijeka. Please, the stage is yours.
Thank you. So thank you for the introduction. And my talk is not going to be about the visualization. My talk is more going to be about the problems in natural language processing in one really not well-defined task. So it was fun doing this, and I will show you results of what we had during the project that was European Horizon project, where we actually wrapped the natural language processing into BI kind of web application. So what was the motivation, and or how has everything started? European Commission actually wanted to reframe the statistical framework, how statistical organizations are monitoring the cultural and artistic activities. Because usually they do a lot of quantitative reporting, which is not totally adequate for what is going on in the culture and art, and they actually wanted to develop systems that can provide more qualitative indicators of what art and cultural activities are actually doing to the society. So, as you see, usually problems in the industry are not that vague. Usually they are much better defined. So, but this is how we started. We got the project, and actually the project was how to assess the value and impact of different cultural policies and practices into the society, and how this social value creation mechanism acts. In some I will spoil my results. In some points of this project, we did a really nice job, but mechanism of transfer is actually deeply understanding of processes going in the society, and this was probably left for the next project. So what we were tasked with actually, because it was given in the proposal, to discover how cultural policies, activities, and practices are actually influencing three categories of the society. First was health and well-being. The second one was which influences does on the urban and territorial renovation. And the third one was how it provides or how it enables better social cohesion of vulnerable groups in the society. Migrants, poor children, maybe some people with some disabilities, and so on and so on. So this was the task, but it was not everything. We also got something in advance, and this is actually the categorization of the cultural sectors. 10 domains, and domains were not well defined. So we had heritage, archives, libraries, book and press, visual arts, performing arts, audiovisual and multimedia, architecture, advertising, and art crafts. So, where was the problem? In heritage, I do have archaeological sites, maybe some natural preserved sites, and museums. At the same time, we really wanted to understand what is the difference between visual arts and audiovisual and multimedia, because they overlap a lot. And we wanted to change these categories, but unfortunately, they were given by Eurostat and actually original proposed by UNESCO, so we didn't want that war, so categories remained as they are. And so the task was actually now, we had three parts of the society, we have not well-defined domain, and we had 30 categories of the data, which was really not well-defined. So what we did, we actually started by the representation of the model into so-called MESOC matrix, which was organized in the database that was called the repository. And the scale of the knowledge organization was actually according to these 30 categories, 10 rows, 3 columns. But I do have more columns here. Intentionally, numbers are not really that important, but I wanted to point out that after collecting in a 1.5 years the document collection, we still ended up with some categories with 0 instances for learning, 0 texts. At the same time, we ended up with a lot of texts that were general and covering all the aspects, or maybe policy documents that were actually related to all 30 categories at the time. And finally, in policy documents, you don't talk about one isolated topic. You talk about many topics, so documents were actually related to several categories at the same time. So we faced the problem, not well-defined problem, then we faced the 0 instances in the data and multi-label data problem. So at that time I thought, oh, this is going to be extremely difficult, because the task was to extract some latent knowledge that was really not clear what this knowledge of impacts and variables and influences in this society is all about. But we ended up with a tool, with the prototype that is running on these links, and actually prototype is wrapping up the natural language processing pipeline in the form of the geo-referenced visualization tool that enables analysis of impacts for the location and provides some visualization of the results in the form of the heat map that actually represented this knowledge organization of the MESOC matrix. So here is not much to say. Actually, geo-referencing was essential because one of the tasks is, one of the goals was to provide the local policymakers enough information how they should plan, or maybe which cultural activities will help them to produce some benefits in the society. So the motivation was really nice, really good, but the definition of the problem is really ill-defined. So this is all actually of the visualization that I'm going to show, because all the results are actually captured around this matrix that represents 30 categories, and it's actually heat map. So no much of the visualization. So as I promised you, I will not teach you a lot about the visualization. But what we have managed is that actually the same visualization element can be used also for the analytical purposes. And I think this is the main added value of this tool that we have created, and because actually user can upload its content, and content can be then analyzed according to this categorized or classified in these 30 categories, and additionally for that document we can derive which impacts are possible impacts that the activities that are described in the user document can be possibly induced in the society. One of the tasks was also to provide semantic search, so some information retrieval, but not only according to the content, which is the standard task, but also according to the impacts or these latent structures that we retrieve from text can be done. The similarity score was not usually used, cosine similarity, but we opted for the Jacquard overlap. due to some reason of the sparse data and discrete modeling of the problem. So now from the matrix, when you select the cell on the right, the possible impacts in the society are found. Now I will need to go down because I cannot read. For instance, in the urban category, you can improve urban marketing or increase a better balance between core and periphery of the city, support the creative industry sectors, and so on and so on. So this is what was retrieved. Here I intentionally deleted the location that we are seeing, but this was the idea. And if you click on health and well-being, then you can see other set of impacts and also for the social cohesion. So this was pretty much the result that was wrapped up in the project. And a user can when selects the document, it can go directly to the document level. What I really think is interesting is this story is how we fix the NLP part, that something like this can even be, may be useful to some policymakers. So, first, the user can upload the document, then we do automatic PDF to text conversion, and then all the documents that are not in English, we are talking about European Union, with all kinds of different languages, Croatian, Serbian, Hungarian, Portuguese, Spanish, Italian, they are translated into English, and then we are on the safe place, because for English, NLP does work. For Serbian and Croatian, we do face a lot of problems due to the morphological richness of the languages. So this is done. Then, since we are dealing with the documents that can belong from 2 pages to 250 pages or the whole books, we needed to downsize the problem for the representation, and we decided to use the keyword extraction. And keyword extraction actually enabled us to extract the most salient part of the text and represent the documents only with this information. And also keyword extraction tremendously reduced the dimensionality of the vocabulary. And then 2 fun parts, where we actually started to do some artificial intelligence and machine learning, the classification part and automatic inference of latent impacts to the society. The keyword extraction, we used the unsupervised Yake, if anyone is doing. We also do have our own method for keyword extraction, but this one turned to be working really nice. So for the classification, remember, I do have the 30 categories with categories that have no representative text whatsoever and really not well-defined categories of the data. So the problem was tough, and I was like talking to many, many people and asking for their opinion, how should we go with it. And then I read tons of papers, and we ended up with some really elegant and simple solution that turned out to be working really nice. So we used 2 random forest classifiers, but on the output we actually had the output probabilities vector to be classified into all classes that were trained in this classifier. So the first random forest was trained for 3 cultural sectors, and the second was trained for the 10 domains. And then we actually multiplied probabilities, cut off some threshold because it was below the threshold that we experimentally determined that it was nice to use this threshold, and then we actually got the final distribution into classes. And these output probabilities are actually also used for the visualization in the heat map. We evaluated with tenfold cross-validation, and for the really not well represented classes, we use synthetic minority oversampling techniques, MOTE, that is actually trying to balance unbalanced data, or to improve classification in the classes that are really underrepresented. So now for the results. This solution, actually, I was really skeptical and said, okay, whatever we got is going to be disaster. But when we tested it for 3 cultural sectors, macro averaged F1 score was between 93 and 96%, and for 10 domains, it was between 93 and 97%. So this was really surprisingly good. So we said, okay, this is ready for the production. This is as good as it gets. We cannot get any better results from this data. And the second problem was automatic inference of the impacts. First of all, impacts are not well defined. They were not annotated in the data. And we had among experts no agreement what impacts are. So completely unsupervised problem without even knowing what we should be getting out of the data. So it was completely, if you're talking about the hidden variable, this is the definition of the hidden. Something that is so hidden that even experts are not understanding it. But that's the fun of doing research. So we started with document collection. Documents were not annotated. And then after 1 year, I actually forced one of the experts, okay, show me what these impacts are. And he ended up in the list of 100 impacts. And this is then, it was breakthrough how we started developing the algorithm. So what we did, we actually everything projected into the semantic space using the word-to-vec embeddings. Word-to-vec was the first choice. We also played with fast text, but word-to-vec works really fine for the problem. And we used the cosine similarity. What we did is actually represented in this pipeline. So first of all, we used the phrases that explain these impacts and projected them with word-to-vec into the space. Then we used all the documents collected in the repository, extracted all unigrams, bigrams, and trigrams, and projected them also into the same space using the word-to-vec. And then we clustered semantic space with these bigrams and trigrams that actually explained what can be terms found near these concepts of impacts. And this seemed like actually, I opted for a really simple solution because we reconstructed that as a baseline just to see if it worked, and it turned out that it worked really nice. So with this technique, with playing a little bit of thresholding, when semantic expansion is too broad, then we have too much overlap between impacts, and when it's too narrow, then I don't have enough bigrams and trigrams in the semantic expansion that I can do the inference later. So, but with these simple principles, we actually manage to annotate all the data and train the model that is capable of retrieving the impacts for the new documents. So, as I said, everything is wrapped up in the toolkit that is available on this link. And for front end, we used React. Back end was Python and Django. And I'm really grateful for a great team of my students that participated in the project. So if you have any questions, otherwise, check what we are doing and the link. Thank you very much. I left enough time for questions.
All right, so do we have any questions? don't be shy.
It's a lunchtime time.
Yeah,
They're hungry.
I guess so. So, speaking of which, first of all, thank you very much, Sandra, for this presentation.
Thank you for the invitation.
It's our pleasure. So give it up to Sandra, please.